In the previous video, we were able to find this integral a sub n. The final result showed us that we had various cases depending on whether n was even or which odd numbers it was. Now let's go on and solve this integral, this b sub n integral. And recall, we've already been able to simplify the integral slightly because we know that our switch goes from 1 to 0, and we also know that the period goes from minus pi to pi, but our switch is only on from minus pi half to pi half, which is the same as the period quarter up to period quarter. So we've been able to make that simplification. So doing that, one more thing that we should recall, that for this pulse, where we have described this pulse with this period, we know that the radial frequency is 1, and so we're going to use that later and substitute in here. So taking this integral, this sine integral, we have removed our WT, and that's because our pulse is 1 to 0, so when it's on, it's 1, when it's off, it's 0, and we're just going to integrate from minus period quarter to period quarter. Now, if we do this integral, we get this minus cosine result. We're going to need to evaluate by substituting in for our period. And further substituting, we're going to substitute our radial frequency. That's going to be substituted in here. Radial frequency substituted in here. And our period, we substitute that in here. Simplifying a bit and evaluating, we get this result. Now recall that cosine is an even function, and by that even function, this means that this part inside of here, right, this is actually going to be equal to 0. So this plus this, that is equal to 0. So therefore, our b sub n is simply equal to 0, much easier than the a sub n.